pH calculations. So this is the basic overview of the different formulas that you're going to use to perform pH calculations. For these calculations, you will need a scientific calculator that has the log function and an exponent function so that we can perform all of this in the calculator. So, when given the concentration of hydrogen ions, or the concentration of hydronium ions, H plus or H3O plus, to calculate pH, we would do negative log of that concentration. When given the pH, we can take 10 to the negative pH to calculate the concentration of hydrogen ions or hydronium ions in that solution. So we can go from pH to concentration of hydrogen or hydronium, and then back to pH, back and forth using these two equations. This central equation allows us to get from the pH side of things to the pOH side of things. Because the pH plus the pOH equals 14. So if we're given the pH and we want to find pOH, we would take 14 minus the pH to give us our pOH. Alternatively, if we're given the pOH and we want to find pH, we could take 14 minus the pOH to get us to pH. So the only way to go from the pH side of things to the pOH side of things is through this equation here. So we can't go directly back and forth between these two. We have to first stop at this step. Now, similar to how we have concentration of hydrogen or hydronium ions going between pH and pH, we can calculate those concentrations from that. We have on the pOH side the concentration of hydroxide ions. So on this side of things, the concentration, let me just fix this table here. That looks much better. Okay, so on this one, the concentration of hydroxide ions, to get to the pOH, you do negative log of that concentration. If you have the pOH and you want to figure out what the concentration of hydroxide ions is, you go 10 to the negative pOH. So we're going to go through some practice problems now. So what is the pH of a 0.1 molar hydrochloric acid solution? So molarity is the concentration of this acid. So this is the concentration of the hydrogen ions that are within this solution. So a 0.1 molar solution has 0.1 concentration of hydrogen ions. So in order to solve this one, we would do pH is equal to the negative log of the concentration of 0.1 molar. Now when you type negative log in your calculator, it typically gives you an open parenthesis, and then you would just do the 0.1. I like to close my parentheses before I press the equals button, just because I like to keep things neat. So I go negative log 0.1, close my parentheses, and press equals, and I get a pH of 1. There is no unit on pH, it's just a number, so pH is 1. So what is the pH if the concentration of hydrogen ions is 7.2 times 10 to the negative 3? So we're going to use the same equation here. The pH is equal to the negative log, and it's going to give me that open parentheses, and I'm going to do 7.2 times 10, and I'm going to use my caret key to go to the and then put the negative key, negative 3, and I'm going to close the parentheses. Here's where closing the parentheses may be important, just to make sure that it does the order of operations correctly. So negative log 7.2 times 10 to the negative 3. Close my parentheses, and I get a pH of 2.14. So now they're giving me pH, and they want to know what is the concentration. We're going to use this equation. So 10 to the negative 4.4 is equal to that concentration. So 10, little caret key, negative 4.4 equals 0.000039811. So if we want to put this into scientific notation, 3.9811 times 10 to the negative 1, 2, 3, 4, 5. And that's my concentration of hydrogen ions. What is the pH if the pOH is 3.4? So that's where we're going to use this equation. To get to the pH, we're just going to do 14 minus 3.4 equals, and we get 10.6. What is the pOH if the pH is 5.5? So we're going to do 14 minus 5.5. We get 8.5 as our final answer. So now we're on the pOH side of things, and it's giving us a concentration of hydroxide ions, and it's asking for the pOH. So in our calculator, we're going to do negative log of 0.1, and our pOH, when we do that in our calculator, is going to be 1. What is the pOH if the concentration of hydroxide ions is 8.1 times 10 to the negative 6? Using this same formula here, we're going to do pOH equals negative log 8.1 times 10 and the little caret key, 6, close the parentheses and press equals. So negative log 8.1 times 10 caret key, negative 6, close the parentheses, we get 5.09. Now they want to know what the concentration of hydroxide ions is if the pOH is 11.4. So if given pOH, we can calculate that concentration by doing 10 to the negative pOH. So 10 caret key, negative 11.4, and we get 3.98 times 10 to the negative 12. What is the pH if the concentration of hydroxide ions is 9.2 times 10 to the negative 4? So now we have to look at this problem because we're given hydroxide ions, but they're asking for pH. We can't go directly from hydroxide ions to pH. In order to get here, we have to first stop in the middle and then we can get over to figuring out the pH. So concentration of hydroxide ions can get us to the pOH. So when we do this in our calculator, negative log 9.2 times 10 to the negative 4, close the parentheses, and we get 3.04 about. And that's our pOH. But they're asking for pH. So in order to get to the pH, we're going to do 14 minus 3.04. And we get 10.96. And that is our final answer. When you're doing these types of problems, it's important to realize what information you're given. If you're given information about an acid, or if it gives you information about pH or concentration of hydrogen ions or concentration of hydronium ions, then you're working on the pH side of things. If it gives you information about a base, so remember the main difference between acids and bases when we're looking at formulas is acids typically start with the letter H. Bases typically end with OH. And of course there's exceptions to this, but just in general, if we're looking at acids versus bases, that's how you can loosely tell the difference. So if you're given information about the concentration of a base, information about the concentration of hydroxide ions, or the pOH, then we're working on that pOH side of things. If they are asking you to convert between something from the pOH side to the pH side, or vice versa, we have to go to that intermediary step. There's no direct calculation where we can just skip this middle step. Okay, so what is the pOH if the concentration of hydrogen ions is 6.9 times 10 to the negative 2? So concentration of hydrogen ions can get us to pH, and then we can get to pOH by subtracting it from 14. When you're taking the exam, sometimes it's helpful to write out these steps. So instead of just grabbing your calculator right away and starting to plug in numbers into the calculator, if you have a flow chart, you can kind of then go back and check your work and make sure you're going on the right path. So we're going to do the first step, negative log of the 6.9 times 10, we're going to do our caret key, negative 2, and that'll get us to the pH. So in the calculator, negative log 6.9 times 10, caret key, negative 2, close your parentheses, 1.16. So we can do 14 minus 1.16 to get to the pOH. $12.8. Or 12.84. So what is the pH of a 0.1 molar NaOH solution? So we're dealing with the molarity of a base, so this can get us to the pOH. And then we can do our 14 minus that to get to the pH. Again, remember to identify what's in your problem before calculating anything. So if we do this in our calculator, negative log of 0.1, we get a pOH of 1. Then we can do the 14 minus that pOH, and that gives us a pH of 13.